Hi guys, welcome to this video today on equivalent fractions. Thanks very much for joining me. My name's Darren, MaffsGuru. Really good to see you. Hopefully you are well, yeah? If you can, like my YouTube channel, like the video. Really important to get likes nowadays. And hopefully just spread the word. Tell your mates, tell your teachers. Today we're dealing with equivalent fractions. Ooh, did you see that? I shuddered. Most people when we go fractions will actually shudder. Why will they shudder? Because, I don't know, they find it difficult. But hopefully after watching my video, you'll make a lot more sense of fractions. That's hopefully what I'm going to be able to do. Because the fractions to me is all about pizzas and chocolate. Thank you very much. Pizza and chocolate, yes. Basically, what are we learning today? We're going to look at what an equivalent fraction is and be able to simplify fractions. Now, you may already be able to do this. You may be a gun. But it's not going to hurt just to review and have a look as well. Some people, if you found it difficult in previous years, don't give up. Your brain develops. It actually gets better year on year on year. And what you found hard last year, hopefully this year you will find quite easy. So I haven't cleared that calculator screen with the stuff from a previous lesson, and yes, that is a calculator. Probably a little bit more a little bit more complicated than the one you've got. By the time you get to year 9, 10, 11, and 12, particularly over here, if you're in Australia, then you will be using something very similar to that. Yes, it does absolutely everything, barring allow you to watch Netflix. Yes, I know. Wouldn't that be great if we could let you watch Netflix? Because then when you're in a maths lesson and you're bored, you can just fire up something that you want to watch. I know, too much information. What is an equivalent fraction? Right. Oh, when I go out, I love pizza. There is nothing better than a massive pizza, yeah? So when we go out, I go to the shop at the end, I get this huge pizza, there's so much meat on it. Thankfully, not an egg. Why do you put an egg on a pizza in Australia? It makes no sense. Yes, if you're watching this in the UK or anywhere else in the world, they put an egg in the center of a pizza and call it an Aussie. Strangest idea in the entire planet. Anyway, feel free to disagree in the comments below if you're watching this on YouTube. All right, so there is a pizza. I'm going to go, now when I go to the pizza shop, I tell them, do not cut this pizza up. Do not cut it up. I want to eat it whole. Every now and again, I have to take my other half with me. I know we have pizza. So, the pizza man looks at me and goes, well, all right then, what I'm going to do is I'm going to cut that pizza smack bang down the middle. I'm like, oh, okay then. So that means that this bit I get, and this bit here, my significant other gets as well. So I get one slice out of the two, and my other half gets one slice out of the two as well. Hold on a moment. That looks so suspiciously like a fraction. Yes, I know it looks suspiciously like a fraction because it is a fraction. That's all a fraction is, 1 out of 2. I've got one slice out of 2. All right? So I said, all right, that's fine. I said to the pizza man, I said, well, I'd like it cut 4 ways, please, because I think I'm going to get more. So he goes, all right then, I'll cut it 4 ways for you. And he looked at me a bit strangely. So assuming that this there is the exact same pizza, what I'm going to do now is he said, right, I'll cut it into 4. And I was like, all right then, well, all right, I've got to do this. So I'll have this piece and I'll have this piece as well. And then my other half can have that piece and that piece. And so what have I got? Well, I've got 2 out of the 4 pieces, and my other half has got 2 out of the 4 pieces. Yeah, I feel much better now because I've got more, haven't I? Well, if I shade the bit I got last time, there is that. If I shade the bit I've got this, hold on a minute, that looks exactly the same. That's not funny. What's that? Oh, no. So I go to my pizza man and I go, no, do it again. I want it cut into 8 pieces. If I cut it into 8 pieces, I'm going to get more. Okay. So the pizza man by now is looking at me going, how many times do you want to cut my pizza? How many times do you want me to cut my pizza? So he cuts it there. He cuts it there. He cuts it along the bottom, along there. He cuts it along there. And he goes, right, all right. So I'm going to get this slice, this slice, this slice, and this slice. Ka-ching! Yes, I'm getting 4 slices. I've got more. Haven't I got 4 slices now? It's more than 2. I've got 4 slices. And my other half is going to get this one, and this one, and this one, and this one. So I have got 4 out of the 8. And all right, they've got 4 out of the 8 as well. But I've got more. I must have more. By this time, the pizza shop guy is going, get out of my shop, right? You're a lunatic. And I'm like, well, that's not very nice, is it? I'm about to pay for this pizza. And he's like, I'm not sure, because it makes it sound like you're going to keep cutting it up. So when I colour it in again, lo and behold, what do I notice? I have exactly the same amount of pizza. I am devastated. So what have I proven? Well, basically, what I have now proven is that, well, number one, I should never go into a pizza shop again. But I've proven something called equivalent fractions, because what I've now shown is that a half is the same as 2 out of 4, which is the same as 4 out of 8. All of these things are absolutely the same. They will give me exactly the same quantity of pizza. And that is why they are called equivalent fractions. They're called equivalent fractions because equivalent means the same. The fractions, they are a fraction. Now, how on earth do we know they are equivalent? Well, we could draw diagrams. That is certainly one way. But we use a process called cancelling down to check whether they are equivalent. So if I had got my pizza guy to actually do 8 out of 16. Now all I'm imagining there is he's cut my pizza into 16 slices, right? So this is the total number of slices here, and that is the amount I'm getting. That's the proportion I'm getting, 8 of them. How do I cancel this down? How do I check? Well, there's lots and lots of different ways. Because both of these numbers here are even numbers, because they are both even numbers, I know that I can divide by 2. All right, I can halve them. Dividing by 2, as far as I'm concerned, is the easiest thing to do on the planet, right? Pretty much everybody I know can halve numbers, right? If I give you number 8 and say, what's half of it? You're going to tell me it's 4, all right? Again, number 2 times tables, everyone knows. But what we got to remember for fractions is what I do to the top, you must do to the bottom as well, right? So you must do to the bottom as well. So if I divide the top by 2, I have to divide the bottom by 2. And I'm going to write equals because by doing that, we're making them equivalent. So I get 4 on 8. Oh, all right. And there we go. Now I already know, because I've seen from my diagram here, that 4 on 8 is exactly the same as 2 on 4, which is exactly the same as a half. So I could now write straight down that that is the same as a half. All right, just ka-ching, thank you very much, write it down as a half. But what if I wanted to just keep cancelling it down? Well, I've got 4 on 8. Remember, we do to the top and the bottom exactly the same thing. They're both even numbers, so I tend to halve it. So again, I always write the divide by 2 and the divide by 2 on the top and bottom just to remind me so that I don't make a mistake. 4 divided by 2 is 2. 8 divided by 2 is 4. They're even numbers, so I can still cancel down. And you keep going until you cannot do it anymore. So again, they're both even numbers, so I'm going to divide by 2 and I'm going to divide by 2. 2 divided by 2 is 1. 4 divided by 2 is a half. And we cannot go any lower. The only way I could divide those is by 1, and if you keep dividing by 1, you're going to get the same number. And lo and behold, there we go. That is, in fact, simplifying. All right, I've just taken a fraction and I have simplified to its lowest form. All right, it's. Now, a lot of people will be going, are you nuts? There was probably a much better way of doing that, because 8 on 16. Now, again, depending on how well you know your times tables will depend on what you choose to do first. I always halve it, just easier. I can halve numbers in my head. But you might have noticed they were both in the 4 times table. So what I could have actually done was divide by 4 and divide by 4. Well, 8 divided by 4 is 2. 16 divided by 4 is 4. Do I finish there? No. And again, every time you write a fraction, ask yourself, is it in its simplest form? Because again, they are both even numbers. And if they're both even numbers, I can divide by 2. And again, that is going to give me a half. But you may also turn around and say, well, hold on a moment. I know that 8 and 16 are both in my 8 times table. So can I just divide top and bottom by 8? Abso-chuffing-lutely. 8 divided by 8 is 1, because anything divided by itself is 1. 16 divided by 8 is 2. And lo and behold, all the same. So it's really, really important to note that when you're doing equivalent fractions, what we're really doing is we're just slicing pizza and we're trying to find out fractions that are the same, just with different numbers. Could I go the other way? Well, absolutely. Let's start with the smallest fraction, my simplest form of a third. So what I'm now going to do is, so long as I do the same thing to the top and the bottoms, but this time we're going to times, because we're going to make it bigger. That's not the right word really, because you're not making the fraction bigger, you're just making the numbers bigger. The fraction is going to stay the same. But if I now multiply the top by 2 and the bottom by 2, I get 2 on 6. So that now tells me that 2/6 and 1/3 are exactly the same. another equivalent fraction. And I could do it again. I could times that by 2 and times that by 2 to give me 4 on 12, 8 on 24, and I could keep going forever. Yes, another example, let's do 3/4, and here I'm going to times the top and the bottom by 10. Who knows, right? So that gives me 30 on 40. Right, so if I walked into my pizza shop and asked for 3/4 of the pizza, he would cut my pizza into 4 pieces, I'd have 3. If I asked him to have 30/40ths, he would definitely throw something at me, but he would cut that pizza into 40 pieces and I would have 30 of them, but I would still eat exactly the same amount of pizza. So let's do some examples. Thank you very much, Cambridge, for allowing me to use your examples. Cambridge Essentials textbook is awesome. All right, so the question actually says that what it wants me to do is to change this fraction here so that the denominator is 40, but to keep it equivalent. Oh, so what we're wanting me to do is pretty much what I did here. So we want to try and make the bottom of the number 40. Remember, the denominator is the bottom. So we have the numerator on the top and the denominator on the bottom. All right, so we want to make the denominator 40. So what I'm going to do is I'm going to put equals and a line, because I know that 40 has to go on the bottom. Now, to make it equivalent, we've got to make sure that we grow by the same amount. Do you notice what I'm doing here with the arrows? So how do I go from 5 to 40? Now, sadly, a lot of people go, add 35. Yes, you could add 35. But when we are growing fractions, when we're using equivalent fractions, we multiply or divide. Multiply to get bigger, divide to get smaller. So we have to look at what do I multiply 5 by to get to 40, and it turns out to be 8. And again, your times tables are really important. Now remember, when we are doing equivalent fractions, what we do to the numerator, we must do to the denominator, and vice versa. So that's got to be times by 8. So 3 times 8, 8, 16, 24. And ka-ching, there we go. That's my equivalent fraction, 24 over 40. Now again, the large number of people will then go, I'm going to cancel that down. No, that's not what they want you to do. If you cancel it down, you're going to get back to 3/5. All right, so a half, it wants this to be a denominator of 40. All right, so let's see. How do we go from 2 to 40? We multiply, remember, have to multiply. We're going to multiply by 20, which means I would have to do the top as well, times by 20. Yep, so that would be 20. Now again, other people do this in a different way. If I want a half and I've got 40 pieces, there's going to be 20 on top. There's another way of thinking about it. All right, a couple more examples. So we're going to make this one out of 40. Look at what I've got to multiply the bottom by. So multiply by 10, because 4 times 10 is 40, which means I would have to do the same on the top. So let's move that down a moment and put times 10. And that gives me 70. Now, what do you notice about that one? It's a top-heavy fraction. That's fine. In this instance, we would leave it as that, right? Because the question wants to just have an equivalent fraction, and that is fine. This one here is a little bit of a trick. Do you see what they've done? They've got you so used to doing it that way, you've got to then say, well, how do I now get from 120 to 40? Because I'm getting from a bigger number to a smaller number, I'm going to divide. So what do I divide by? 4, 8, 12, I divide by 3. So I'm going to do the same here. I'm going to divide by 3. 36 divided by 3 is 12, and we have 12 on 40. Yes? Easy peasy lemon squeezy. We love this. All right, last 2 examples now. They say cancel these down to its simplest form. All right, simplest form means I've got to get it down as low as I possibly can. Well, I'm going to follow my rule of halving because I like that one. So the first thing I'm going to do is I'm going to divide each of these numbers by 2. All right, so I'm going to just divide by 2 and divide by 2. That gives me 4 on 10. Have I finished? Nope, because they can divide by 2 again. So divide by 2. And divide by 2. Now you're going to turn around and say, do I have to keep doing this? Well, I always tell my kids to keep doing this. 4 divided by 2 is 2. 10 divided by 2 is 5. Can I go any lower? Nope. And ladies and gentlemen, there is my simplest form. 2 out of 5. Yeah. The only thing I could divide both of those by would be 1, and that would be completely pointless. Let's look at this one here. So what am I going to do? All right, what goes into both of those numbers? Well, 2, no, because they're actually odd numbers. 3 is not going to 25. I'm going to try 5 next. So actually what I'm going to do now is divide both of those by 5. Notice what I did. And if you don't understand why I chose the numbers I did, there's a different video on there. So 15 divided by 5 is 3. 25 divided by 5 is 5, and I cannot go any lower than that. 5 on 3, because again, well, they're both prime numbers. So they're only going to divide by 1 and themselves. And ladies and gentlemen, I can't really see what could be any more complicated than that with equivalent fractions. Hopefully it has been a good video and that you have understood. Remember, the notes can be downloaded from MaffsGuru.com. If you can, subscribe, like the video, and tell your mates and teachers. If not, hopefully I'll see you in another video. You take good care. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is MaffsGuru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.